Hi everyone, so this is our third session together. We're learning about the sun and its apparent movement into the sky. So I say apparent because by now we are becoming quite clear on the idea that the sun only appears to move. It does in fact stay in the same place, but as the earth rotates, it changes position in the sky. So the sun's apparent movement across the sky. So we begin So guys, we begin by reviewing this through watching a quick 2-minute summary clip of our previous video. Yeah, we then talked about our first tasks finding, guys, and what we learned from this task. So to summarize our discussion this session on our findings, we all observed that the shadow of our cups, we all observed, guys, that the shadow of our cups shifted with the direction of light. When we changed the position of our torch, the shadow that our cup cast also moved. And the shadow got shorter as we moved the torch closer to the cup and longer as we moved it away. It sort of stretched out, one of you said. So I'm really impressed with all of the ideas that you shared in our session. So this session, we reviewed how the same happens when the sun changes position. The shadows of objects that the sun's light falls upon shift as the sun's position changes in the sky. So yeah, so to recap, shadows will shift along with any movement in the source of light. We looked at the cup's shadows shifting with the position of a torch, as I just said, and the same thing applies with any source of light, be that a torch, a light bulb, or the sun. So guys, we really looked at this in detail in this session. I'm really impressed with some of your ideas. So guys, the shadows of objects that the sun is shining on, again, they also shift throughout the day because the sun's position, as we've been looking at, changes throughout the day. So the shadows of objects that the sun is shining on also shift throughout the day. So I was really impressed with one of you who explained that she's seen this happening to the shadow of her house, how it's on one side, one part of the day, in the first part of the day, in the morning and the afternoon, and afterwards, after midday, it's on the other side. So excellent, guys. That's the shadow showing how the sun's light is changing, how the sun's position is changing in the sky. Excellent, guys. So in the olden times, they actually used the changing position of shadows to tell the time. They didn't have clocks in those times. So they used the sun's changing position to tell the time. And how they would track the sun's changing position and know what time of the day it was by looking at its shadows. Because again, wherever the sun is in the sky, it will cast a shadow, and it will cast that shadow in the same place every day at the same time. So guys, they track the movement of the position of the sun in the sky by looking at the shadows that objects cast. And they use that as a kind of clock, as they didn't have a clock in those times. Guys, let's kind of, let's to visualize this, let's watch a video on this. So in this session, we watched a video on how that looks in practice, guys, how it looked in practice in the olden time. Guys, I'm just going to open that up for you now.
Have you ever noticed, maybe on a nice summer evening and you're running around outside, that your shadow looks super long, but then at other times of the day, it's really short? What's up with that? Does your shadow have a mind of its own, like Peter Pan's? Nope. I mean, I hope not. That'd be strange. To understand how shadows move over time, let's talk about what a shadow is exactly. Say you're standing outside in the sun and you spot your body's shadow. Your body is solid. That means it can block sunlight. Since sunlight can't pass through your body, it makes a dark area behind it, opposite from the direction the sun is coming from. This dark part where the sunlight can't reach is your shadow. So why doesn't this dark patch stay in the same spot throughout the day? Well, for one thing, you move, so your shadow moves with you. But let's pretend you stand in the same spot all day long. No, wait, that sounds super boring. Just picture something that doesn't move around, like a tree or a building. Its shadow would still move throughout the day. That's because the shadow is made by the light of the sun, and the sun is constantly moving in the sky. Well, you know it's not really the sun that's moving. You should definitely check out our video about how the Earth moves or rotates on its axis, making the sun appear to move across the sky. Even though it constantly seems to be changing where it is in the sky, some people know exactly where the sun's going to be at certain points during the day. In fact, ancient civilizations thousands of years ago used the sun like a giant clock. They could tell what time it was based on the sun's position in the sky. How'd they figure that out? Because the sun follows a certain pattern every day. These civilizations saw the sun rising in the east and setting in the west, day after day. Soon they were able to guess what time it was based on where the sun was on its path from east to west. Cool, huh? And since the movement of the sun follows patterns during the day, so does the movement of shadows. Any idea what those shadow patterns might look like? Let's find out. We'll follow the sun for a day and see how it changes the shadow of a specific object. Then we can chart the length and the direction of the shadow from morning to evening to see which patterns we can spot. First, let's pick an object that stands still, not running around all crazy. Like, how about a lamppost? Same one that's about 4 meters tall. Now let's start early in the morning, 7 a.m. Sun, show us what you got. The lamppost has a pretty long shadow this early in the morning, and it looks like it's extending to the west. What happens to the shadow if we fast forward to 9 a.m.? Interesting. The shadow's still pretty long, but not quite as long as at 7 a.m. And it's still stretching out towards the west. So let's see what happens at 11 a.m. Well, look at that. The shadow's even shorter, but again, still pointing westward. So in the morning, it looks like the lamppost shadow starts out long and gets shorter as we get closer to noon. But they all extend to the west. What happens at noon? Hardly any shadow. The sun is high in the sky at noon, almost directly overhead. Depending on where on Earth an object is, its shadow will usually point north or south at noon, rather than east or west. Let's see what happens to the shadow in the afternoon, jumping to 2 p.m. Looks like the shadows are getting a little bit longer again, now that the sun's going lower in the sky. But unlike in the morning, the shadow is now pointing east. Will the shadow continue to get longer at 4 p.m.? Yep. It's definitely getting longer, still pointing east, too. How about 6 p.m.? The shadow's about as long as it was in the morning, right? But again, unlike in the morning, the shadow is stretching out towards the east. So what patterns did we see the lamppost shadow follow? Let's look at these two bar graphs that recorded our observations. In the first graph, we've charted the length of the lamppost shadows. Based on what we observed with the lamppost, the sun created long shadows in the morning when it was rising in the east. When it was almost directly overhead at noon, the shadows were shorter. Then, as the sun set in the west in the afternoon, the shadows got longer again. And what did we observe about the direction the shadows were going in at certain points of the day? Well, like the second graph shows us, we saw that the shadows in the morning and afternoon faced two different directions, and the midday shadow was somewhere in between. So graph number 1 shows us that when the sun is low in the sky, shadows are long. When it's high in the sky, shadows are short. Graph number 2 shows us that whatever direction the sun is in the sky, the shadows it creates will point in the opposite direction.
Guys, graphs are really useful.
So now you know what a shadow is, and that it changes in both length and direction during the day, depending on where the sun is in the sky. Basically, the sun is your shadow's boss. Yes, sun, no sun, whatever you say, son.
So guys, to explore what we learned today further about the shadows cast by the sun, I'd like you to try task 2. So your first task was the task with the torch. So I'd like you to try this task by either making a sundial or drawing and noting down your observations of an object's shadow when the sun shines on it. So track its changing position and draw it. Like, for example, one of you described their house. Draw that. Where is it in the first part of the day and where is it in the second part of the day? So what happens to the shadow's position? So you can either draw or take pictures of your findings, or take a picture of a sundial, guys. So guys, this is a video on how to make a sundial. I'll post this for you below. And it looks something like this. So you could use something round, cut something out, or draw a circle on a piece of paper, and then stick a straw through it and put it outside, and sort of mark where the shadow is, so you can put, if you put a straw in the middle, or you could put something else like a bottle even. So if you put a bottle in the middle, and then draw where the shadow is and what time it was. And then at another time of the day, where's the shadow now? And then mark it. So you don't have to do it every hour. You can do it at different times and just mark those different times onto your piece of paper. Yes, it will allow you to see sort of how the shadows change throughout the day. Yeah, so it'll give you a better idea of that, guys. So I hope you enjoy the video, and I hope you've enjoyed your tutorial. So enjoy tracking the changing position of shadows, and we'll talk about it more in our next session, guys. See you.